right, we're back here talking about how light reflects off smooth, curved surfaces. Starting up here, we're on page 96 and 97 of your book. Concave mirrors. Not all mirrors are flat. A mirror that curves inward is called a concave mirror. Like the mirror in the figure below, a perpendicular line to the center of the mirror is the optical axis. The law of reflection determines the direction of reflected rays. When rays parallel to the optic axis strike a concave mirror, the reflected rays converge and come together. So here we are, parallel, and they come together. Focal point. Look again at the figure below. Notice the point where the rays converge. Converge means come together. The point where light rays parallel to the optic axis converge after being reflected by a concave mirror is the focal point. Imagine that a concave mirror is part of a hollow sphere. Sphere is like a ball. The focal point is halfway between the mirror and the center of the sphere. The distance along the optical axis from the mirror to the focal point is called the focal length. Okay, from the concave mirror to where the focal point is, that's the focal length. The lesser the curve of the mirror, the longer its focal length. The position of an object compared to the focal point determines the type of image formed by a concave mirror. Here's some useful information. This explains how a satellite dish works. A satellite dish. A satellite dish is a concave mirror that scientists use to communicate with objects in space. A satellite in orbit sends electromagnetic waves to Earth. The dish-shaped shape bounces the magnetic waves to the focal point. At the focal point, there is a sensor placed at the focal point that receives the signal. Very cool. Moving on to convex mirrors. Convex. Now there's concave and there's convex. Convex mirrors. Have you ever seen a large round mirror in the center of a hallway, like in a store or something? The mirror enables someone to see places they cannot see with a plain, flat mirror. And they can see around corners where someone else may be walking. A mirror that curves outward, like the back of a spoon, is called a convex mirror. Light rays diverge or spread apart. Spread apart is to diverge, spread apart, after they strike the surface of a convex mirror. Moving on to the types of images. You will not be quizzed on these. These are less important, but interesting nonetheless. Types of image. As shown in the figure on the right, the image a concave mirror forms depends on the object's location relative to the focal point. The image is virtual, meaning it's not really there, if the object is between the focal point and the mirror. Okay? So if the focal point's here, the image is virtual. The image is real if the object is beyond the focal point. A real image is one that forms where rays converge. No image forms if the object is at the focal point. No image forms. All right. 3D thinking. Let's see how well you've retained this information. Sketch a model of what happens to light in a convex mirror. Convex mirror. If you forgot what a convex mirror is, you can review it right here. Convex mirror. All right. So here are the things you need to include in your drawing. Make sure you include and label all these parts. Make sure you have the curved surface. Okay. Have light rays that go towards the surface. These are called the rays of incidence. They're going toward the surface. Please make sure you show me how they're bouncing off and coming back to the focal, tell me where the focal point is. You can use some dashed lines to show where the light would be kind of bouncing off, even if you can't see it. Yeah, so here's all the things you need to include in your drawing. You do need to draw how light occurs when hitting a convex mirror. I'm not going to draw that for you. You can do that. And then the question that goes with this is, how does the structure of convex mirrors support the function of side mirrors on cars? So as you're driving along, those mirrors that are on the sides of cars, those are actually convex mirrors. Now, how do they help? Why are they shaped that way? Why use a convex mirror? Well, here's a sentence frame to get you started. A convex mirror allows drivers to see what? Because the reflecting rays do what? Okay, what does a convex mirror allow drivers to see, and why? Why does it allow them to see that? How are the rays, the light rays, acting? All right, the last thing we need to do before moving back to our evidence in our CER is get our foldable. Remember our light foldable? We've already talked about electromagnetic waves. We've talked about how light interacts with matter, transmission and absorption. And we've moved on to the law of reflection, how it reflects off a smooth flat surface. Today we moved on to a smooth curved surface, and then next week we'll move on to a rough or uneven surface. So you want to take the two pictures from today's book on page 96 for concave and convex mirror, and you want to try and draw those again here for concave and convex. I would also label those in case you forgot what concave and convex. Concave is an inward curve, and convex is an outward curve. Okay. All right, let's head on back to page 88 for our CER. Here we are. For letter B, what evidence have you discovered to explain how light reflects off a curved mirror? Here's a sentence frame to help you out. Light rays that hit a curved mirror reflect at what kind of an angle, at which compared to how they hit the mirror. But the light rays either do this or do this, depending on whether it's a convex or concave mirror, okay? Whether it goes in or out, okay? Whether it's curved in or curved out, okay? It's gonna do this or this, okay? And that's it for this week. Have a great weekend, Matadors, and I'll see you next week on Monday.